Hi everyone, we are from Group 4 and today we will introduce about the topic of radioactive. First of all, radioactive pollution is the contamination of the environment by radioactive substances that emit harmful ionizing radiation. This substance can contaminate the air, water, soil and living organisms. Exposure to high levels of radiation can damage cells, cause genetic mutation, increase the risk of cancer and negatively affect ecosystem. Radioactive pollution may result from nuclear power plant accidents, improper disposal of radioactive waste, nuclear weapons testing, or industrial and medical activities involving radioactive materials. Then, we talk about the difference between radiation and radioactivity. Radiation is the energy emitted in the form of waves or particles. It travels through the space and can pass through the materials. Radioactivity is the properties of unstable atoms that causes them to emit radiation as they break down into more stable forms. Radioactive materials are used in many important fields. In medicine, they help treat cancer and diagnose disease. In electricity generation, nuclear power plants produce large amounts of low-carbon electricity. In industry, they are used to inspect pipelines and ensure product quality. In research and agriculture, they help improve crops, preserve food, and support scientific study. Although radioactive materials provide many benefits such as saving life, producing clean energy, and supporting the scientific progress, they also carry risks. High exposure to radiation can cause cancer, damage cells, contaminate the environment, and produce long-lasting radioactive waste. Therefore, radioactive materials must always be handled safely and responsibly. Thank you.
Here are some common examples of radioactive materials according to Bahar et al. India study. The first one is uranium-235. It is mainly used as fuel in nuclear power plants because it can produce huge amounts of energy through nuclear fission. Next is plutonium-239. This is a man-made radioactive material used in nuclear reactors and also in nuclear weapons. Another example is cesium-137. It is produced during nuclear fission and is commonly used in medicine and industry. However, if it escapes into the environment, it can remain radioactive for many years. We also have iodine-131, which is actually very useful in healthcare. Doctors use it to diagnose and treat thyroid diseases because it is absorbed by the thyroid gland. The last one is radon. Radon is a naturally occurring radioactive gas. It can build up inside homes and buildings, especially in places with poor ventilation, and long-term exposure can increase the risk of lung cancer. Now, let's move on to our case study, the Kishtim disaster of 1957. The Kishtim disaster occurred on 29 September 1957 at the Mayak nuclear complex near Chelyabinsk in the former Soviet Union, which is now Russia. It is considered one of the worst nuclear accidents in history. This accident started when the cooling system of a radioactive waste storage tank failed due to leaking pipes. As the tank became hotter, pressure built up until it exploded. According to a study conducted by Soviet and Ottoman, the explosion released about 70 to 80 tons of radioactive waste into the environment. The waste contained dangerous materials such as uranium, plutonium, strontium-90, and cesium-137. The effects of this disaster were devastating. Around 20,000 square kilometers of land were contaminated, affecting rivers, forests, and farmland. Many farms became unsafe because the soil and water were polluted. The disaster also affected people. Around 27,000 individuals were exposed to radiation, and many later faced a higher risk of cancer and other health problems. Because of the contamination, entire villages had to be evacuated and the affected area remained restricted for many years. The Kishtim disaster reminds us that one failure in safety can have serious consequences for both people and the environment.
Assalamualaikum. My name is Shahnas. My number metric is A212920. So today I'm presenting a case study on the Church Rock uranium mill spill, one of the worst radioactive polluted accidents in US history. The accident happens on 16 July 1979 in New Mexico, USA. A dam used to store radioactive uranium mining waste broke, releasing millions of gallons of radioactive wastewater and a large amount of uranium waste into the Puerco River. This polluted the environment and affected nearby communities. The main cause of the accident was the failure of the tailings dam, which was built to store radioactive mining waste. The dam had poor design and structural weakness, causing it to collapse. When it broke, radioactive wastewater and uranium waste flew into the Puerco River. Some reports also mention problem with the waste storage system. Leaking coolant pipes caused the cooling system to fail, allowing heat and pressure to build up inside a storage tank. This eventually leads to a chemical explosion, releasing more radioactive materials. Overall, the disaster was caused by poor waste management, weak dam construction, and inadequate safety measures. For the environmental impact, the Church Rock spill had serious environment consequences. First, the Puerco River became heavily contaminated with radioactive materials. Large area of surrounding lands and soil were also polluted by uranium waste. Plants absorbed radioactive substances from the contaminated soil, while livestock and wildlife drank contaminated water and ate contaminated vegetation. As a result, radioactive materials enter the food chain through a process called bioaccumulation, where harmful substances gradually build up inside living organisms. Even many years after the accident, radioactive contamination remained in the environment, affecting nearby communities and limiting the safe use of land and water resources. For the health effect, the radioactive pollution caused serious health problems for people living near the area. Long-term exposure to uranium and radioactive materials can increase the risk of cancer. Uranium can also damage the kidney, and radiation can damage DNA, which may cause genetic changes. The Navajo Nation was one of the most affected communities because they used the Puerco River for drinking, farming, and raising livestock. Many people were exposed to the contaminated water for a long time. And for a long time consequences, the effect of the Church Rock uranium mill spill continued for many years. People living near the area still face a higher risk of cancer and kidney diseases due to long-term exposure to uranium. Radiation may also damage DNA, and these effects could continue into the future generation. Even today, some areas remain contaminated, and the Navajo Nation continues to face health and environmental problems caused by the spill.
My name is Daniel Shaira Menzari A212747, and I'm going to explain why monitoring radioactive pollution is important. So firstly, monitoring can provide an early warning because, as Adiola et al. Emphasized in 2022 review, if we detect contamination before it reaches a harmful levels, it can allow us to prevent a catastrophic health and environmental consequences. So this is actually important, right? Especially around the mining sites and also nuclear facilities, where the radionuclide concentration can exceed the global average values. So secondly, monitoring can also ensure public health protection because by continuously measuring radiation levels, we can prevent human exposure to hazardous radionuclides like uranium-238, thorium-232, and also cesium-137. So which Adiola et al. In 2022 reported that it can cause cell damage, cancer, and also DNA mutations. So thirdly, monitoring can also allow us to filter performance checks. As Clark et al. In 2023 described how the alert system continuously tests air after carbon filtration in collective protection shelters, we can ensure the crew remains safe from the chemical and also radiological threats. And finally, monitoring can also provide data for decision making. Of course, if we can inform emergency response actions and also long-term remediation strategies when contamination is detected. Now let's look at the first monitoring method, which is by using inductively coupled plasma mass spectrometry, or ICP-MS. So according to Klicker et al. In 2024 paper published in the Journal of American Chemical Society, ICP-MS is an important tool in radiopharmaceutical science because the instruments ionizes samples at approximately 7,500 Kelvin and separates ions based on their mass to charge ratio, or M to Z. So Klicker et al. In 2024 reported that ICP-MS can quantify metals down to nanogram per liter or even sub-nanogram per liter levels. So it makes it extremely sensitive for detecting metal-based radionuclides. So its advantages are high sensitivity, multi-element capability, and also wide linear dynamic range. So however, the authors also noted that there's also limitation, which are polyatomic interference such as argon, that can affect the measurements for masses below 80 daltons. The next monitoring method is the Geiger-Müller counter. So Clarks et al. In 2023, in their work on air pollution and radiation monitoring in collective protection facilities, they explained that the GM counter detects ionizing radiation through gas ionization in the GM tubes. So this device, as shown in the slides, it measures the gamma radiation dose rates in air with a detection range up to 100 gray per hour and an accuracy of plus minus 15%. So the authors also highlighted that the response time is immediate, with detection possible at absorbed dose rates as low as 0.6 to 0.8 microgray per hour. So this fast response, right, is important in emergency situations because it allows us for immediate activation of protective measures when high radiation background is detected.
Hi, my name is Haziq, and for my part, I will explain the control strategies for the nuclear and radioactive materials to minimize environmental pollution and protect human health. The first strategy is strict government regulation. Government should establish and enforce comprehensive laws and safety standards to ensure that the radioactive materials are handled, transported, and used responsibly. The second strategy is emergency preparedness and public education. Emergency response plans should be developed and the public should be educated on the radiation safety and the appropriate actions to take when a nuclear emergency happens. The third strategy is safe storage and disposal of radioactive waste. Radioactive waste must be stored securely and disposed of using an appropriate method to prevent contamination in the environment. The fourth strategy is environmental monitoring around the nuclear plants. Regular monitoring of air, water, and soil parameter can help in detecting any radiation leakage in the early level, and this can ensure that the radiation levels is maintained around within the safe limits. The fifth strategy is regular inspection of nuclear facilities. Routine inspection and safety audits help ensure that nuclear facilities comply with regulation and maintain high safety standards. And finally, the last strategy is wastewater treatment before discharge. Wastewater generated from nuclear facilities may contain any contamination and should be treated and tested properly before being released to the nearby water bodies. This can prevent any contamination that will occur. In conclusions, handling radioactive materials can potentially give risk and harm to humans' health and environment. However, with proper management and practice, we can get benefits from the nuclear technologies, in areas such as energy generation, medical application, and scientific research. Therefore, effective monitoring and pollution control measures must be implemented to prevent radioactive contamination and maintain the radiation levels within acceptable limits. These efforts play an important role in preserving environmental quality and protecting safety and health for both humans and wildlife. That's all from our group. Thank you.